Coming up on this episode of This Week in Space, we're going to talk with Dr. Elsayed Talaat of the University Space Research Association. We've got space in the name, so you know we love it, and you know you want to be there. So don't miss it. Tune in.
Podcasts you love
from people you trust.
This is Tweet.
This is This Week in Space, episode number 146, recorded on January 31st, 2025, all the way with the USRA. Hello and welcome to another episode of This Week in Space, the all the way with the USRA edition.
USRA!
USRA! We'll get you another letter for your Letterman's jacket for USRA. I am Rod Pyle, editor-in-chief of Bad Astro Magazine, and I'm joined to my warm and fuzzy glee by my friend Tarek Malik.
Hello!
Editor-in-chief at the one, the only, space.com. Hello, partner.
Yes. Hey, Rod. I'm so excited to be here. You said we were going to be talking about universities, and I am wearing my USC Letterman's jacket, like I said I would last episode, to celebrate, right? We're going to just talk about our rivalries. Is that what we're talking about today?
There is no rivalry. I went to Stanford, which is an actual university, not a place for spoiled children to buy their degrees.
Wow.
Oh, dear.
Wow. I thought
this week.
I was teeing you up for our guest, but thanks for the spike in the eye, Rod.
Sorry. This week, we'll be speaking with Dr. Elsayed Talaat, who is the new president and CEO of the University Space Research Association, which is a group we're talking about. Space. Which... It's funny, you know, I didn't know much about them until a few years ago when Soraya, I guess she's administrative executive associate, something, reached out to me and started telling me about the work they were doing. I thought, wow, this is great. So we started carrying articles about them in the magazine and so forth. And they're huge in the university and space industry research world, putting those people together along with NASA. So they're a really cool outfit, and we're going to learn more about that shortly. But first, we need to ask you to not forget to do us a solid and make sure to like, subscribe, and do the other cool podcast things, because we need your love. We need your love. All right.
You have my love, Rod. You have my love, you know.
You. And now...
Don't make it weird.
We'll repair our traditionally tragically unfunny humor segment with this joke from, I hope I pronounced this right, Janko Strauss, who's a physics student. Hey, Tarek.
Yes, Rod.
What did the astronaut say to her lover?
What did the astronaut say to her lover?
Are you approaching apogee or have you fallen for me yet? That was a small...
I love it. It's an orbit joke.
I'll take that one. Now, I've heard that some people want to blow themselves in the asteroid belt when it's joke time of this show, but you can help by sending your best, worst, or most indifferent space joke to twists@twit.tv. Because unless we've used it at least once, sometimes a couple of times, I keep them all and I put them in a roster, and we do scroll through them and we give you on-air credit. Although if you don't want credit, you could tell me that. And it's a lot of fun. All right. So let's go to some headlines.
Headline news.
Oh, I always miss it.
Man, Anthony is on it with the push buttons, isn't he?
I tell you, I was going to try to lip sync it, but she says headline news like earlier than when I think it's going to come, and then I miss it like entirely. So
I'll send you the file so you can listen to it 100 times.
I'll rehearse.
So from space.com, as most of our stories are, we have an errant asteroid sighting.
That's right.
Thank you, Mr.
We're going to
Musk.
lead with that one? That's the one that we're going to lead one? Wait, yes. We got a couple of asteroids. That's right.
Yeah.
That's right. It's the asteroid that wasn't actually. And this is actually a story that came up at the American Astronomical Society. I was walking through the, what do you call it? Like that place with all the booths, the event space. Anyway, I was walking through that, the exhibitors, the exhibit hall, and astronomer Jonathan McDowell pulled me aside, space tracker of Jonathan's space report, also at Harvard Smithsonian, and he's like, "Hey, did you know about the asteroid that just got deleted?" And I was like, "No, John, tell me more." and he told me this wild story about how astronomers found an asteroid earlier this year, like just at the turn of the year, and it turned out that it was not an asteroid at all. Like the next day, they realized that it was Elon Musk's Tesla from the Falcon Heavy launch in 2018.
Right.
Because it's still up there. They launched it. It's orbiting the sun, right? And so they had to delete it. And the Minor Planet Center, the group that announces the new discoveries, that gives them their names and all that stuff, had to actually issue a retraction to delete the entry, delete the asteroid from the records, because it is not an asteroid at all. And Jonathan actually talked about this at AAS during a panel called Dark Skies, and it was one of a couple to talk about just the issues that astronomers are facing in this more modern spaceflight era. And he told me on the phone this week that it's actually something that is not very uncommon. In fact, NASA's old WMAP space telescope, space observatory at L2, was miscategorized as an asteroid many times during its mission life, because astronomers would be looking out there, on the night side of Earth, and it was at L2, a million miles away, opposite side of the sun. And they would think it was an asteroid until it fired its thrusters and started moving, and then they're like, "Oh, we gotta go back." So at the time,
although Avi Loeb would be very excited about that if it turned out really was an asteroid that was firing thrusters.
Yeah. So at the time, it wasn't like a huge problem, but it was just something that was an annoyance. But we are in a new era now. SpaceX launched 134 Falcon missions last year alone, more than most countries do. And a lot of these countries, or a lot of these companies, and some countries, some of the new players, are just throwing their upper stages out into the cosmos rather than having them re-enter, because it's easier to do it that way. And they're getting lost out there until we rediscover them years later, and we think that there's something else. Now, why is this important and not just, a funny story about Elon Musk's car in space? Well, because these astronomers are trying to get an accurate picture of the solar system, of where stuff is, of where these asteroids are, and more importantly, where these near-Earth asteroids are, because we need to know where they are so that we can need to know if some of them are a problem or a threat that we're going to have to deal with if it's going to come smack us in the face, a decade plus down the line. Having an inaccurate census of that is going to be an issue. And similarly, as more and more of these companies become more active in space, there's a whole space transparency knot about who's responsible for what. Jonathan told me, if on Earth we have to file flight plans to fly from city to city. So why would you not have to file a flight plan if you're going to another planet, for example, in space? Why not? It's pretty basic. So they'd like to have a database set up for that. And there are other companies like AstroForge, which actually came up from some of our readers in the comments while we're recording this video, who have tried to keep things on the DL, right? Because of proprietary information. AstroForge is a space mining company that wants to mine an asteroid, reap all of those juicy metals that it has, and make a profit somehow. And for a long time, because they're launching a mission in next month as we're recording this, but weeks away from us recording this, they are launching a mission to said asteroid. They weren't telling people where this Odin spacecraft was going to go, because they didn't want their competitors to know. Well,
don't want claim jumpers out there.
Exactly, right. But that's an issue, because if astronomers don't know that there's a spacecraft out there, going to an asteroid, they're going to think that those spacecraft that they find could be another asteroid, mistake it for something else, and then you have this inaccurate picture again about what's actually out there. And so that's a really big issue. The American Astronomical Society released a statement last September, of which Jonathan was part of the subcommittee that did it, calling for more transparency from these companies and these government agencies as they get more active in space. And it seems to have had an effect, because this week, as we're recording this, AstroForge announced what asteroid they were in fact going to go to. And the CEO there said, in part, it was because they wanted to calm some people down. They saw the pushback from the scientific community, and they wanted to identify it. And it's called, actually, what is it? It's called 2022 OB5. It's a 100-meter plus S-type or M asteroid. So, and M-class asteroid, pardon me. And they're hoping that people might look at it, share data with them, and then they'll get more information about it as they get ready to fly there. So it seemed Jonathan called that kind of a big victory for space transparency. So that's great that's happened, but that's just the tip of the iceberg. There's a lot of more of these companies flying, so it is an issue, not just a funny story. And I just thought I'd like to highlight that for our top story today.
All right. Well, now that you've been chewing scenery for about 17 minutes, why don't you pick the next story? Because we're probably going to run out of time.
All right. Well, let's pick one that you grabbed then. You know, you picked the SpaceX and their last Dragon from Mike Sheets over at CNBC.
It sounds like a kid's movie, doesn't it? The Last Dragon.
I know, right?
I saw that and I thought, oh, so they're building their last, they're completing their fifth Crew Dragon capsule. I don't think this includes the cargo Dragon capsules, Dragon 1. Because they can fly so many times, I guess they figure this will last them until Starship comes online, which we hope is not too distant a future. At this point, the 5 Dragons are rated to each fly 5 times, in theory, which would be 25 flights. But they are talking about trying to rate them, if NASA agrees, for 15 flights, which kind of puts them up in space shuttle territory in terms of visibility. Yeah. That's astonishing.
Didn't Discovery flew like 25, 27 times, something like that?
I don't remember. A lot, yeah. But still, I mean, this is, and you know, I mean, kudos to NASA. This is a lot simpler than a space shuttle. It's smaller, it's less complex, it doesn't have to fly through the atmosphere and come in for a landing and all that kind of stuff. But still, you know, for a private company, which has not been doing it that long, less than 10 years, in terms of crewed flights, way less than 10 years.
I find this story very interesting because it feels like a sea change or a turning point in like the whole commercial crewed flight operations.
Sure does.
We've had this whole buildup over the last 10 plus years to, first of all, build a spacecraft and then to fly them, get them operational, which they are now, I think we can all agree, to the point where they're reflying them over and over again. And now here we are at a point where they're going to say, you know what, we have enough. We have our stable of ships. We think that they're dependable. We don't need to build more multi-million-dollar ships for now, which of course is what NASA did at the end of the 80s when was it 90, whatever, when Endeavour like finally rolled out. And then that was it for 30 years, 20 years. That was it. That's all we had. And now SpaceX seems to be at that turning point too. Or they're going to pull something else and have a whole other vehicle, and then Starship, you know, which they're going to say we don't need more.
Oh, because we can fanboy!
We can launch 5. Are we going to talk about that? No, I guess we're going to now. So, but anyway, I just thought it was very, very interesting. Plus, this was from LinkedIn. This is a newsletter that Michael Sheets writes. I'm going to have to make sure that I subscribe to this. So.
Yeah, it's a good newsletter. I just get the teasers for it. I guess we really can't close this off without you talking about the 200-foot wide asteroid that's going to come wipe out downtown Los Angeles in a decade.
Or is
not
it?
Even a decade, 7 years.
No, it's got like a
1.3% chance.
That's right, and a non-zero. Like it's 99% not going to hit us. But this was announced this week. Actually, this is from space.com. This is a story that my colleague Rob Lee wrote. But there is an asteroid, a near-Earth asteroid, called what is the name of this asteroid? I didn't pull that up. Oh, 2024 YR4. Why are me? You know, is what I'm wondering right now. But it may make a close approach to the Earth in 8 years, and it's between 40 and 100 meters wide, according to the scientists that we spoke with.
Oh, so this number we had was an average.
Yeah, well, yeah. It's about that's the range, right? That's like the range.
So wait, if it's got a 1.3% estimated chance, and obviously they're going to refine that as they keep observing it, how does it equate to 1 in 83 chance? I'm a little confused here.
You know, I asked Rob the same question. It's a math thing. I think that 1 in 83 is 1.2% chance is what that is. And NASA actually put out a statement, a very short one, about earlier this week. You know, to try to remind people not to get too carried away. You know, they said it was a more than 1%. And about 99%, more than 1% chance of hitting, but then that means it's a 99% chance that it's not going to hit, and that people shouldn't like freak out. In fact, Heidi Hamel over at the Planetary Society, they have a really great rundown about this asteroid, and she just reminds everyone you've got more chance getting hit by a car than getting hit by this asteroid. So,
well, having been hit by cars 4 or 5 times in my life, that's not terribly comforting.
You know what? I just realized that you and I are like in the same boat with that, because I have been hit like 4 times too. Yeah.
Yeah, but did you ever have a complete rollover?
No.
Those are exciting.
No.
Yeah.
No. I almost drove off into the LA River though because I spun out on the freeway. So, yeah.
And I went through all that trouble to spread that oil, and it just didn't work.
You. No, it was a giant traffic cone the size of a person lying in the front of the road at 3 a.m.
Oh, we used to call those plastic pedestrians. We'd go out and run them down late at night because I was very young. Don't get any ideas. I was a teenager, but
So that was you that was throwing them on the 710 freeway on the way.
Oh
into
my
Long Beach.
God!
Yeah.
They were stupid enough to give us driver's licenses at the age of 16. What did they expect? Oh, this is fun.
Speaking of that, congratulations to my daughter Zadie. She passed her driver's ed test today.
Oh,
also,
good.
this week it's our 20th anniversary for my wife and I for our wedding anniversary. That's exciting.
Any other? You want to tell us about your gallstones or anything?
Oh,
I mean, as long
wait!
as
This
we're
is our
here.
news section. This is news that's important to me, everybody. So,
Jeez. Let's see. Do I have anything? No. My life is so plain and ordinary. Well, I lost 5 pounds, but that.
hey, that's great. Well done.
Hey,
where's the thing, Anthony? Come on. Where's the horn? There we go.
What do they call those things? Anyway, I'm sorry. We're burning too much time here. Good. Is there anything else we want to cover, or did we hit our mark?
I think that's enough for now. So
Okay, so let's
we'll
we're
save
going to
some
go
of this
to
for next week.
Yeah, we'll go to a quick break here, and we'll be back with Dr. Elsayed Talaat, and we'll talk about the USRA, which is going to be a very cool conversation. He's an interesting guy, so don't go anywhere. That's an order. Welcome back, everyone, and we're here now with Dr. Elsayed Talaat and his history, talking about the University Space Research Association. And this is a group that I've been aware of for a number of years, thanks to a woman named Soraya who works there that's been very good to me and provided me with a lot of material over the years. And Elsayed, how long have you been the chief of the organization now?
This is day 5.
Day 5.
Wow.
It's been fantastic. And I'm very excited and enthusiastic about heading up and helping them. And also very excited to talk to you guys.
Well, that's great. And I'm really excited for you in this new position. And I've admired this organization for a long time, which has its origins back starting the same year as the Apollo 11 landing and largely in service of the Apollo program, but I was going through your website earlier this week, and I'm literally stunned at how much territory you folks cover with the USRA. I mean, it's just amazing how many things you're involved with. So maybe you could talk about the organization a bit, if you would.
Yeah. As you said, it was started in 1969 to really by NASA and the National Academies for Science and Engineering and Mathematics or Medicine, excuse me, and really to bring researchers from universities to work on NASA projects and NASA problems, particularly the lunar samples and at the time, and has grown into many areas of innovation and discovery that it's done, including a lot of workforce development that USRA has done over the years and continues to do.
And for you, I'm curious what brought you to space in general, because of course this isn't your first rodeo. You were, I believe, you were the director of the Office of Space Weather Observations, right, at NOAA most recently. But you have a long history with space. What brought you to space in particular? Was there something when you were a kid that hooked you when you were young, or was it something that you found later on while studying something completely different?
Just about everything in space hooked me when I was a kid. I wanted to do anything above the ground, anything flying, anything orbiting, anything exploring out into the solar system. I mean, certainly I remember getting National Geographic's, the old ones, the gold ones, and seeing all the Voyager pictures, and the different times it's visited the different planets, and just being amazed by the discovery that was going on. So I wanted to always work in space, and I thankfully I've gotten the opportunity, both from kind of building instrumentation to look up with satellites flying through, and also doing a lot of different science projects that address different aspects of space. And what attracted me to USRA is the breadth, as you said, of everything that it does. It really does. The heliophysics, astrophysics, and earth science, and as well as space nuclear propulsion. Very, very cool, and something that's preparing for the future. And really new breaking things with AI and ML and different techniques that are being developed in some of our institutions here. And then also very cool things with International Space Station and low gravity science. And what I really was excited to be to come here for is that breadth there, and also the kind of that cross fertilization that you can have in such an organization. So where traditionally we've seen science being done kind of in a siloed fashion, where you have your astrophysics, and then you have your earth science, and you have your data analytics, for instance. With USRA, what we have going, and what I'd like to see grow, is kind of the cross collaboration across these disciplines, and using the techniques that each discipline has, and seeing if it applies other ways, and then using the new techniques we have for artificial intelligence, machine learning, and applying them across USRA.
It took me much too long to realize, when you said AI and ML, that ML was machine learning. So I think that I've learned nothing from these machines, right? So,
no, they're learning from us.
was there? My most direct next question was going to be, what was it about USRA that really grabbed you? But you kind of touched on that. But I'm curious, just kind of given your background with, most recently with space weather, but with that space hook, is there like one specific section that you really gravitate to the most? Like when you're on lunch break this week, settling in, which division do you kind of go and hang out with to see all the cool blips and beeps that are going on the computers behind them?
Absolutely not. There's all of them.
No favorites, like a good parent. Like a good parent.
All of them are very interesting, and they're all interesting in unique ways. I'm learning something new. I've been here for 5 days, but I'm learning something new every day about each different activity that we do. For instance, I did not know that USRA has been in the artificial intelligence business since the 1980s. Wow. And so some of the first applications for using AI for deep space exploration were done by USRA in collaboration with others, and then just more recently, I mean, it's not just historical, but more recently, they've implemented AI in how air traffic control happens. I know this is a very, very sad day for us in this area, but that they've demonstrated that in Houston for efficiency and coordination of planes using AI and ML in that application.
Yeah, that's a real world,
exciting.
Yeah, real down to earth type of applications there too. That's great.
Right. So I think we have examples of that across all of our disciplines, where you have the institute in Huntsville that's doing heliophysics work, and you mentioned space weather, which has applications towards national security and space situational awareness that not only our industry needs, but our national security partners also need that understanding. And then the Earth from Space Institute, where it's mapping all the greenhouse gases that are being emitted, because we really have to understand our environment. And so that these applications are not just they're cutting edge science, but they have real world impacts that we can use now.
So you said something before that caught me because I'm a nuclear propulsion fanatic. I don't understand it as well as I should, but I am excited about it. I was a big fan of the NERVA program from what little I knew about it when I was young. But what is your involvement? Because that really does seem to be, we look at what SpaceX is doing a Starship and think, well, great, we can make it to Mars in 6-ish months maybe. But nuclear propulsion really seems to be the holy grail, at least for the near term. What's your involvement there?
So we have the Center for Space Nuclear Research out in Idaho Falls. That really is an incubation hub for not only workforce development in terms of internships and scholars, but it's also new partnerships with industry, academia to advance space nuclear propulsion. And that's one of the things I'm learning about right now that I'm very excited about, because I really do see this as key to our exploration future, both from a commercial standpoint, but also from a scientific standpoint. Understanding and developing that technology is going to really be a game changer when we go out into the solar system, that's where we're building that capacity out in Idaho, and it's a very exciting development. We have just broke ground on we just built a new facility to provide space for these innovative projects and activities there.
So I'll assume that's a conventional fission reactor heating up fuels for high ISP, as opposed to another one of my favorites, which is Project Orion nuclear pulse propulsion.
I will have to get back to you on that. I don't know enough about that to answer that
no problem.
Correctly.
Project Orion was a little bit on the science fiction side. It was a design that ejected small nuclear warheads out the back of the spacecraft. But I mean, it's Freeman Dyson and a bunch of other people at General Atomics, so it apparently would work. But launching it's a little nasty. We're going to pause here for a quick break, and we'll be right back. So stand by.
Well, it's 2025, which is a new year for us. I know that we're kind of just rounding out the first month of the year, but we're at the start of a year. You're at your start at your tenure at USRA, and I'm curious, kind of what you see on the horizon for this year or just overall as either like the biggest challenge facing the group or your scientists overall this year that you're hoping to achieve, or maybe like the big project that you want to have that notch in your belt for by the end of the year.
Well, I think we have a lot of different activities that we have going across the organization. Each has its own different milestones, et cetera. But I'm looking forward to some of the discoveries we're making coming out. We just had a recent paper, for instance, in that went out about looking for water on the moon, and how strategies to how to bring that back. So when we're talking about how this applies to future exploration, these are the type of studies that are ongoing right now. But I think it all starts, in my mind, with the workforce development efforts that we have. That's a big part of our efforts here, and it's a very important efforts. Part of my life was spent in the mission development business, right? And so we talked about life cycle. The life cycle for reviews of developing a mission, et cetera, from formulation to end of mission, right? What I think of when I think of USRA, we do the whole life cycle for science. We start with internships and scholars and postdocs to really grow that workforce. One thing that I saw from being at NASA, NOAA, and even when I was at Johns Hopkins Applied Physics Laboratories, we didn't have enough pipeline of engineers and scientists for the work we wanted to do. And so our as a nation, our ideas are necessarily very grand, and we need to develop that workforce to tackle it, particularly with the explosion that we've had now in the space commerce and space industry. And so the need for this is only going to grow. It's not going to dissipate.
I have a perfect pivot because, and this is something that really struck me when I was reading more about the USRA. The name university is in your title, and you have 113 university affiliations, at least that's what was last posted, which includes Canada, 4 in Europe, 2 in Israel, 1 in Australia, 1 in New Zealand, 1 in Hong Kong, 2 in Korea, and 2 in the United Kingdom. Can you talk a little bit about how these collaborations came about and what the effect of them is?
Yeah, well, that's a big important part of what we do, and we actually have 121 now.
Wow.
Wow. And what a consortium means for us. First of all, it's who really that we respond to. So this Council of Institutions selects a board of trustees that selects the leadership of USRA. So we really respond to this Council of Institutions, and what we provide for the universities is not only a networking function so that they can have colloquia and fora to talk about space research, but we also provide advocacy for their interests in space research, for different aspects in terms of, for instance, science funding, or different things that they want to see facilitated or expedited, like ITAR issues, this international technology exchange issues. So those type of things is what USRA has historically done, and so that consortium helps us not only pick the things that we're going to focus on, but also the things that are important to the academic community, and therefore important, and also important to our stakeholders in the government, like NASA, National Science Foundation, etc.
I think people kind of underestimate the challenges of ITAR. I've only really gotten tangled up in it twice, not in a way like I did something wrong, but
well, we know you're always trying to get those secrets, Rod.
That's it.
He's always trying to get secrets from me all the time, but I never tell.
One was a book I did with JPL, which had to go through ITAR clearance, which was a jaw-dropping experience, and the other was a conference I was at where I was being, how should I put it? I was being befriended by a couple of Chinese folks who had an awful lot of questions. Then because I was writing a book that included news about the Chinese space program in it, I started asking them questions, and their English ability faded very quickly. And I realized I had been mined a little bit. And so a NASA person there said, you might want to be a little more, yeah, okay, even though I wasn't officially employed.
It was you!
Yeah, it was me. I leaked the plans for Project Orion
sink
to China.
Spaceships, Rod.
Anyway, I'm sorry, Tarek, you had a question.
Well, it sounds like an ambitious slate, I'll say it, of not just science ambition, but of coordination and cat wrangling. Because I can imagine that scientists alone, when you put them in a room together, are hard to manage. But like 120 plus institutions, and with all of these different subject lines, must be really difficult. So I'm just curious, because you touched on it a bit about some of the organization, how USRA keeps that science flowing, and then I have a follow up just about how it all gets paid for in a minute. So how is it structured in a way that all of the agencies, all of these affiliations can contribute to the overall mission of advancing space science overall?
Well, like I said, they help advise us through. We have different councils within this council of institutions, and we have different working groups, excuse me, like the space nuclear working group that we're setting up to talk about the universities that are very interested in practices and then how to foster innovation in that realm. And then in general, they, like I said, they help us identify areas of advocacy needed. And we talk about ITAR. We helped reform kind of the condition, change category 15, which it made it less burdensome for professors to teach space science abroad, for instance. So that's how kind of the interaction works. But we also have we touch upon these universities in our research and then the activities we do, not just through the internship and postdoc programs, but in research at the different institutes that we have. Often and almost always have a collaboration with a nearby university.
Got it. So there isn't an official USRA science handler, a science wrangler to herd those cats. Like, not right now, right? Maybe that's like something that you might find as the new chief that you might need, right, to keep folks alive. That sounds great.
My whole career, it's been about collaboration and the power of collaboration, and so it's something that, you know, with it may seem a little bit chaotic and Brownian motion here and there, but we're by making the right connections and making the right relationships, you can accelerate. Can be a force multiplier of getting results.
So like, you were all basically researching the future. So I'm very curious, because you are a nonprofit, how this all gets paid for. I mean, is it all through contributions? Is it through federal agencies? Because we know that that's kind of being looked at right now by the new administration. There was a lot of chaos this week, but it seems like it's working itself out. So how do you kind of fund everything to keep those projects going?
So most of our funding comes from NASA. Okay. And it is through most of it is through competitively sourced contracts, cooperative agreements, grants, etc. We also have funding from the Department of Defense through the Office of the Air Force Office of Scientific Research. And the department, some from Department of Energy as well, but the bulk of it comes from NASA.
So my next question, we're going to take a quick break, but then I want to talk a little bit about the range of scientific investigation you covered, because as I mentioned, it was pretty jaw-dropping. So everybody stand by. We'll be right back. When I go on the USRA website, and we just saw a second ago for people watching the video stream, and you pull down those little circles with the different areas, it just kept going and going and going and going. Yes. And you know, there's some stuff that's tangentially space oriented, and then many things that are directly. There's AI. There's quantum computing, which is we're not hearing as much about that these days because AI has kind of stomped it out of the news. But there's a lot of amazing stuff. So is USRA's role primarily to connect institutions, both professional and educational, in their efforts on these things, or how does that work?
Certainly that's part of what we do, but a lot of but also what we do is advance those areas. So when we're talking about astrophysics, for instance, we're part of a CubeSat that's going to make measurements of gamma ray bursts. We are also have a project that's going to provide data to the whole astrophysics community at over different time domains and all across the electromagnetic spectrum for low gravity science that we do, the microgravity science that we do. It's enabling some research that's happening, but also actually developing different projects that are going to fly on the space station. And so we have a mixture of both. Like I was starting to say, we do it from the whole life cycle, from the beginning, and then really exploiting the data when it gets to us. Whether it's Earth imaging data, astrophysics data, heliophysics data, or using the data in innovative ways with AI, ML, for instance.
So I have a follow-up, Tarek, if you'll indulge me.
No, go ahead. Of course.
I'm going to ask you one of those awful look in the crystal ball questions. So we're all scratching our heads over AI, especially with DeepSeek, the news that came out of there, which was apparently a little embellished, but it still was pretty arresting. 5 years. AI, quantum computing, maybe the two of them combined. Do you have any thoughts on that?
Well, I'm very excited for the future of it. I think it's always a little uncertain how a new tool is going to be used. We have precedents at least in my lifetime with the internet, cell phones, etc. But it's going to help us accelerate our progress, and particularly our scientific progress. So I think what we're just starting to scratch the surface of how we can apply this to different problems that we've had, and across the board from a scientific standpoint, from lost languages, for instance, this outside USRA's purview, but also something I think would be very exciting if it was applied to, and then within our efforts, how we're going to apply that to the space weather, for instance, and other areas of where we have a large data set that we can mine and understand, and advancing our kind of the basic principles, taking the first principles into predictive capability.
Very well said, and I occasionally reflect on, being the old man in the room, I occasionally reflect on the pace of technological advancement, thinking back when I was young and there was no such thing as portable music, and all the shots of the moon landings during Apollo were done with a 16 millimeter camera that you didn't see anything from until they got back, and some poor nervous technician had to actually dip it in a bunch of chemicals for us to see the pictures, and if he messed up, that was the end of it. Okay, Tarek, I'm sorry. Your turn.
I like how you said that you're the old man in the room, and out of all three of us, Elsayed is the only one that doesn't have a gray beard. So,
True.
So our guest. So, no, speaking of tools, I was one of my favorite, I guess, institutions or parts that I had grown up with as a kid. I was surprised when I began working at space.com, was overseen by USRA, which was, of course, the Arecibo observatory in Puerto Rico. I guess the late Arecibo one now, and it was an icon for astronomy, and that I think a lot of people, if you aren't familiar listeners and viewers, it's where Ellie goes to find the alien signal in contact, right?
Right.
And I'm as an organization, as folks that are really heavily invested in such a tool, but one that had been in use for a long time. I'm curious what Arecibo, meant to USRA, and what dealing with that loss, just because, through age and whatnot, things get old, and then they fall apart, and that's kind of what we saw there. What that was like, and what the future might bring for future instruments, that kind of thing.
USRA's involvement in Arecibo is a little bit before my time. But I can tell you as a researcher in my past career, Arecibo was a big part of what we were doing, not only from an astronomy standpoint, but also from a upper atmosphere, ionosphere, looking at the ionosphere, looking at the thermosphere standpoint, and it was a huge kind of observatory from that standpoint that gave us observations that were only available in a few places around the world, and so it was a great loss for across several disciplines. And the nature is as it was. The hurricane knocked it out, but those type of facilities are often where scientists can train, but it also is some things can only be done from the ground, that can only be done from a large facility like that on the ground, that can't be done, for instance, from space. And so there's a need for those type of facilities for different aspects of upper atmosphere, earth science, and then of course astronomy as well.
Yeah, I have hopes for Arecibo 2. This time it's personal. Honestly, just something bigger that can reclaim the record, right, from China's fast, so that we can find those discoveries a lot faster. All right, to you,
we still have many more James Bond movies too.
That's right.
Yes,
Tarek, you need to get over Arecibo.
They filmed GoldenEye there, right? Wasn't it GoldenEye?
Yeah.
That they
Down, boy, down.
Yes.
Two other areas that I found really fascinating, and I'd certainly like to invite you to talk about any areas of emerging research you're involved with that you're fascinated with. But two that I thought fascinated isn't the right word. They're really urgently important for space infrastructure. Is space power systems and cryogenic propellant management, both of which have been tough nuts to crack. So space power systems, we've got these stadium-sized solar arrays now out in the deep solar system because I guess we don't have enough plutonium to make the RTGs the way we used to. So that's certainly something that's hopefully emerging. And then the propellant management. Could you touch on those?
Very lightly, I would say, in the sense that I do think this is why we need to do the research and development on our space nuclear systems, and getting to the point where this can be used in a sustainable and safe fashion for exploration. Not only deep space exploration, where there's an obvious need for it, but even just commercial long-term exploration. So where you don't have to worry about eclipses, you don't have to worry about, like you said, cryogenic systems that need a lot of power, and so that's why I'm very, very excited about the Center for Space Nuclear Research.
I was curious. We talked a bit about funding earlier, and kind of how you mentioned your funding comes from NASA. And there's a lot of questions right now that are going on. Obviously NASA's going to get a new budget, hopefully in the next couple of months, and then discussions with the administration about, fund and grant freezing. But there's other issues I think that really affect USRA's mission, as I understand it. And I know we were talking a bit about this with Shreya earlier about the impact that immigration or diversity or workforce structures might be. I'm curious how you're preparing, or if you can even prepare for a lot of those challenges, given such an international and a widespread reach with the different organizations that are all part of USRA.
Yeah, as you mentioned, we have international universities as part of our consortium, and kind of that exchange of ideas is important to any research that's done, whether it's space research or other research. Our programs are in workforce development, have some visa holders that we we're training again as part of that pipeline of researchers that we can use as a nation. We of course will follow all applicable laws and direction that we get from NASA, our main stakeholder, but others as well, Department of Defense included. I don't see us having any danger of not being able to do the research that we want to do.
Mm-hmm. All right, we're going to run to one more break, and then I want to talk about the part that I really got excited about, which is the university side and the opportunities for students. So stand by. We'll be right back. I guess I keep saying this is the part really excites me. So I apologize. I'm excited about a lot.
He likes everything.
Well,
he likes everything.
It's a cool organization, and there aren't many, if any, others like it. So, can you talk a little bit about how you engage with universities? I mean, you've kind of touched on, how you wire them together with professional organizations and NASA and so forth. But if I'm a student and I'm looking at USRA through my institution, whether I'm undergrad or graduate, what are some of the opportunities, programs, involvements that you would have?
We have quite a few and if I start listing them, I will certainly forget some. So I would recommend that people go to our website, which is shown right there, usra.edu. But in general, we have programs with the Space Force and the Air Force for internships that are tackling problems with Air Force research laboratory personnel. We also have scholars programs with the Department of Defense as well. And then we have internships. You've talked about I think we've talked about the Lunar Planetary Institute, which actually
we didn't. I was going to ask you about that.
That is the part of very early on in the history of USRA that was established to share research and to add in to basically innovate research and invigorate research around the lunar samples, and that was been a part of USRA for decades now, and it has internship programs that have been ongoing for a long time. In fact, when I was at a conference a couple weeks ago, a few people came up to me and said, "I was a USRA intern, and that's what got me in the space field." And I was like, cool. "This is like, well, I should have gotten their written permission." It's like, I want to use this as an example in my last talk.
Absolutely.
And so they've it's really been a very wide-reaching program. Not only from planetary science. In fact, the person who talked to me did not end up doing planetary science, but was in the still in the space field because of that internship. They didn't go the scientist route, but they went another route. And so I think like I said, we have a lot of different opportunities. Please come to the website usra.edu.
I think internships are very important. That's how I became part of space.com, and it's been 20 years plus, and now I'm, get to be the big poobah. So I think that they're very important.
No. Excuse me. I'm the big poobah. It says so right there.
You're the grand poobah. He's the big poobah.
I'm grand poobah. Sorry. Yeah, you can read better than I can. So I want to talk about you a little bit more for a moment. Did I read this right, that you have 60 journal papers and have contributed to 400 conference papers relating to atmospheric and space sciences?
Been around for a while. Yeah. Yes. So
not as long as I have it. I think I've been in one journal. I mean, this is astonishing. How do you keep that pace up?
That was in the beginning of my career. I was a research scientist, and I was lucky enough to be part of different projects. and I always throughout my career I like to work on different things, a portfolio of different things: earth science, planetary science, which I'm very much in love with, and then heliophysics, which is the science of space weather. So the sun, solar physics, etc. And so that's what I did early on, and that helped prepare me for when I went to more programmatic roles at NASA, and then more development roles and programmatic and development roles at NOAA. And then, like I said, USRA kind of combines all of that into one organization. It's very exciting. And when I was at APL, I had a lot of interns and postdoc, etc. This combines it all into one organization, and so and across many different disciplines.
Yeah, I think that we kind of hinted at it.
That's what modesty looks like. Okay,
no,
just so you know.
No. I was born to shine, Rod.
So your mother keeps telling you. Sorry, go ahead.
No, I was going to say, we kind of hinted about this earlier when we were talking, but I don't think that we explicitly went in to detail. But I mean, you have your Master's of Science in Atmospheric, Oceanic, and Space Science from the University of Michigan, PhD, right, in Atmospheric and Space Science from there too. And then you're at Johns Hopkins University Applied Physics Lab. By the way, that's a really cool place, just in general. For 15 years, where, like you mentioned, you were section supervisor, right, for Earth and planetary atmospheres, and then all the way up to chief scientist of the heliophysics division at NASA. We should have really led with that in the beginning.
You're right.
Earlier. Right. So I feel like we buried the lead on your pedigrees there. But I'm just curious how you got into, how that path has really informed your role, or what you see the role of science and space exploration as part of science, in both, the importance of that to both like our society today, and maybe just because it is the USRA, and I'm being liberal with the US there, part to NASA and to the country as well.
I mean, space research has been the source of so much innovation and discovery. Not only discovery from a scientific and kind of intellectual curiosity point of view, but it's also been, how are we able now to have this booming commercial space industry? It's because of the research we did, both engineering development that we did, sponsored by the government for deep space exploration, et cetera. And as well as understanding our space environment, such that we can go out with somewhat of confidence, and with the systems that are protected enough that we can do kind of all this commercial activity. And it's also so important to understanding. Not only looking out in astrophysics and space physics, but looking down at Earth. That's what we really had a huge step function and capability enhancement by having the weather satellites go up, for instance. And now there's commercial weather satellites and commercial data, but it was that big jump for our capabilities from a predictability standpoint by having those observations there. And so it all starts with kind of intellectual curiosity that has these applications that come very soon, frankly, that the research to operations cycle is happening a lot faster now than it did in the past, and research to operations to commercialization, really. That's what's happening these days. And so and then, as I mentioned, looking at different spectra for astrophysical phenomena is applicable to looking at different spectra for solar phenomena, applicable to looking at different spectra for planetary, and then looking at using those techniques for different sensing that we might do of the Earth, might do of terrestrial terrestrial aspects like vegetation, for instance. So all these techniques, you can be as I do, have a lot of fun agnostically, being agnostic to discipline, but saying, okay, what can I do with this technology, and what can I do with this technique? And so it would be, it's a lot of not only innovation, but it's a lot of fun, I believe.
Yeah. Well, that's great. I did have one extra question, and I apologize. It's a little bit off topic, but it lends to your strengths. Elsayed, and that is you were at NOAA. You worked in space weather. You were chief scientist for heliophysics, and we're in the middle of solar maximum, or at least at the start of it, when the sun is at its peak. There were two big M flares just today alone, and I'm just curious, as a scientist, what you think that people should know about both the promise of understanding the sun and its space weather, as well as the risks to like the technology that we use, the astronauts that are in space, that we need to keep that study going. Because I think most people they think of the sun and its weather as, hey, it's a Northern Lights machine to get us some pretty lights in the sky, and it's a little bit different and more important than that.
It absolutely is. I mean, the space weather happens all the time. We just see the beautiful manifestations of it, the aurora, but it's largely an invisible phenomenon. So sometimes it's hard to communicate that this is just as dangerous as a hurricane or just as dangerous as a tornado. You don't see it necessarily, but it has the potential of these large explosions off the sun have the potential for damaging our power grids, affecting our civil aviation. Irradiating our astronauts and pilots, etc., and then disrupting our communications and navigation systems. So that always has that potential, and we have these very large storms that could happen. And we've been lucky so far that we haven't had one hit Earth for a long time now. We had some. If you remember last year, there was some very beautiful aurora that were going on, and that was a large storm, but it wasn't the superstorm that we're worried about. But what also people don't see is the observing system and the research that we've done, and setting up the observing system and the modeling and the forecasts and warnings help protect us from the effects of these storms. So we can sit back and watch the aurora. So when I was at NOAA, I would say that if we do our jobs right, you don't notice anything about space weather other than beautiful aurora, because we can warn warn industry to take mitigative action. We can warn airlines do divert their flights away from polar regions when there's a huge geomagnetic storm, and power grids do take mitigative action with loading, etc., so that there is not disruption to your power. And then we're still learning about the effects, and because we're more and more dependent on our technological infrastructure. So this last storm, farmers, it was during peak planting season. And farmers couldn't plant the crops. They use these sophisticated navigation GNSS global navigation systems to plant their crops now. And so when that was disrupted, they lost that valuable crop planting time. There was one article that said that could have been up to $500 million worth of loss there. And so we need that research to understand the environment better. Space research, not only for space weather, but also space research in itself is key to, kind of our, you're talking about China, but just in our international technological advantage that we've had and want to maintain in the United States. And it's also very key with space weather, terrestrial weather, very key to our national security and understanding that. So we want to understand, and then looking long term, We need to understand the environment for sustainability. Things have been rapidly evolving, and we need to understand how that's going to develop just from our sustainability as a nation and species going forward.
It's good that space research is in the name at USRA. Then you've got it covered.
Yes.
Well, it's good. It's good to know we'll have a warning before the next Carrington event, before the telegraphs blow up.
That's right.
So, I guess my closing question is, if you have advice, and I know you're just getting settled in there, but just an overarching advice for young people looking to get in these fields, because they can now. I mean, when I was young, you either worked for a defense contractor or NASA, or you just did something else. And there's so many opportunities now, and it seems like USRA is able to help channel people in positive directions.
My advice is get in it. Get in on the ground floor. You want it is not only important work, but it is a lot of fun. Discovery is one of the most fun things to do, and every kid knows it, and you can continue that as an adult. But you'll also see how your work affects not only the body of science that goes forward, but really has real world applications that help society here. And so that I'd say absolutely. This is a great time to get in. We have more capabilities than we've ever had before. This is the golden age of scientific observations, and it's also the golden age, kind of the new frontier, I would say, of space commerce and space exploration. So this is space research is only going to take off.
That is a great message, and we hear things similar to that from time to time, but I don't think I've ever heard them said with such obvious passion, and it's really clear that you love your work, and that's just great. So kudos to you, and I want to thank everybody for joining us for episode 146 of This Week in Space, called All the Way with the USRA. Dr. Talaat, is there anywhere besides the usra.edu website we should be tracking the cool stuff you're involved with?
Go to there first, and then it'll take you to all of our different activities and sites.
Great. Tarek, where can we stalk you these days?
Well, you can find me thank you so much for joining us, Elsayed. You can join me at space.com. As always, we've got 2 rocket launches this weekend as we're recording this episode, which is very exciting, including a JAXA H3 rocket. And on the Twitters, or I guess X and Blue Sky at Tarek J. Malik. And this weekend, if you play Fortnite, you can join me with OG Season 2. We're one step closer to an astronaut season. I'm very, very excited. And I'll see you there at Spacetron Plays on YouTube.
I honestly do try to take it seriously when you say those things. But okay. And of course, you can find me at pilebooks.com. where I will soon be lodging my 21st book, or at astromagazine.com. Please remember, you can always drop us a line at twit.tv. That's TWIS at twit.tv. We answer every single email, and we love getting your messages. New episodes of this podcast published every Friday on your favorite podcatcher, so make sure to subscribe, tell your friends, and give us good reviews. And, the usual thumbs up or 5 stuffed bunnies or whatever they've got. And finally, don't forget, we're counting on you to join Club Twit in 2025. Besides supporting Twit, you'll help keep us on the air. We think that's a good thing. And bringing you great guests and horrid space jokes. And you can get all the great programming with video streams and no commercials on the Twit network, as well as some extras that are only found there. And it's just $7 a month. I ask you all, what else can you get for $7 a month that's as much fun as this?
Nothing.
There you go.
There you go.
Okay, you answered the question. And it helps keep the warm electrons flowing to you from our florid minds. Last thing, you can follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook, and twit.tv on Instagram, and I guess I ought to say at Twit on X. But
I was going to say something, but I didn't want to cut
I'm too old to change. So thank you. It's been a real pleasure having you today. You're a wonderful guest, and I wish you all the best at the USRA, and I think this will be another golden age for them. So really appreciate it.
Thank you very much. Thank you. It's been a pleasure talking to you.
Yeah. If you enjoyed your time here, then the next discovery could use the name Rod Tarek or Tarek Rod. I think Tarek Rod is better, but I don't know if you've got any pull. Let those scientists know.
We let the scientists decide. I'm not going to tell them what the name is.
Darn.
Thank you. Thanks so much.
I almost got a tardigrade named after me up in the Arctic from my time up there with Pascal Lee, but unfortunately it turned out there weren't any tardigrades in the sample, so all I got to be named after me was a little spot of algae. All right, sorry. We didn't really need to talk about that. Thanks, everyone, and we'll see you next week.